Longest unit value path. I'm not sure if the path is the longest, but one thing I know for sure is that I am the longest. Okay, shoot. Okay, get back to the question. Okay, hold on, before we do that, let's start the timer. 15. Alright, given a binary tree, find the length of the longest path, where each node in the path has the same value, and this path may or may not pass through the roots. I can take a look at the node. The length of the path between two nodes is represented by the number of edges between them. So, for example, here in this graph, we have one length is 1. So we have a path of length 1. And this is the length 1. For example, this case, the longest unit path value is 2 because as we can see, we have 3 identical numbers. We have 3 identical nodes here, node values here, and then we have 5, 5, 5, and in between them we have 2 edges, which is these 2. And now another thing is, in this example, we have 4, 4, 4, and the longest path is 2, right? Because as the question says, may or may not pass through the root. So this case, well, this is kind of passing the root, but this example, it's pathing, what the heck? Is passing the roots. So 4 is going through the root and then reach the other side. So in this case, longest is 2. Okay, so the given binary tree has no more than 10,000 nodes, and the height of the tree is no more than 1,000. Okay, this is kind of a giveaway. It's telling you to do depth search. Like, I hate when they give you notes like this because during a real interview, the interviewer is not gonna tell you, note, the given binary tree has not more than 10,000 nodes. If you know how to do depth search, you'll get this offer from Google. Congratulations. No, that's not gonna happen. Okay, but since they already told us, obviously, well, this is a depth search question because first of all, unique path, right? Once we see whatever path, then we know this is depth search because with breadth search, you can do path, but it's always not a straightforward way. Actually, I can't really think of a way to find a path with using breadth search. So when you see whatever path, the first thing that comes to your mind should be depth search, right? Like go deep, go deep, Anyways, how much time have I left? Okay, 12 minutes. Okay, now first thing first, longest. So how do we keep track of this longest, right? To keep track of the longest variable, if we have a local variable among this recursion, then it'll be really hard to keep track. Then the first thing we come to mind is we need to have a variable, a global variable that keeps track of this, the length of this path. So we'll have an int and we'll say max length, and it's going to be integer max value. Oh, I'm sorry, maximum length. So instead we should use minimum value so that whatever value we have will overwrite this minimum value once we do the comparison. Okay, so now we have this maximum length, and then what we need is so once we push the recursion down to the bottom, we need to revert it back by checking if the value of the node is the same as the current. The current level, the value of the current level is the same as the upper level, right? Once we do this induction. So we need a helper function that has the current node and also the previous node. Or we can do just do the value of the previous node, because we don't actually care about the node itself. We care more about the value. So before we do that, we need to do the value check. So if root is equal to null, if it's null, then let's not do anything. Why am I returning 0? Yes. And so next thing is we're going to have a helper function. It has a current node, which is root in this case, and the previous node, and the value of the previous node. Now, what's the value of the previous node of root? In this case, we'll put root itself, because at the end we can just void the total length of the root, so that it won't count itself as 1. Alright, I'm just trying to make sure time. Okay, dot root top value, is it value or val? Okay, so val, and then we'll return the max length. Okay, so now let's implement the helper function. Helper. So I'm giving it an int, the return type of the helper function, as int, because once we do the induction or whatever recursion, we'll need to give the current path to the left node and the right node, so we needed to return a number. Now helper. This Chinese restaurant has the strongest dumpling flavor I ever had. Like they put this they put a lot of salt and MSG in it. I'm still burping right now. Don't order this restaurant. Oh, never mind. I won't say its name. But it's a Chinese restaurant in San Francisco. Anyways, we have a helper function, and then now, of course, we have the root, so it's going to be a tree node. I call it node, and the value, which is the value of the previous node, right? Let's call it val previous node. Okay. Now, first thing first, if this node is null, then we just return 0. Second thing, if it's not null, then now it's time to do the reduction. The recursion, I mean. And we'll assign the length of the longest path of the left side to the left. So on the left side, it's going to be a node dot left, and then the previous node is the current node. So node value. And right, same thing. We'll have the right node and pass the current value, the value of the current node. Okay. So we have left and right. What's the next thing? What's the next thing? What's the next thing to do? So say we have the pass number coming from left and right, and then next thing is we need to see. Okay, so we need to see if left side is if the left side is left side and right side, which one is longer, right? So we need to compare left side or right side, which one is longer. Or can we compare? Oh wait, well hold on. We can compare which side is the longest, right? So the max length will be So left plus right compared to the max length. Man, I hate Chinese food. Okay, so now you have the left and the right, and what you need to do is to combine them and then compare to the max length, right? So you will have max length compared to left plus right. Okay. If so, if left plus right and can compare to max length, right? Now another thing is if the current node is equal to the previous node. If the current node is equal to the previous node, then we need to check. Then we need to check that which side of the branch is the longest. So once we have reached this step, so this step is to getting left, right? And this step is to get the length of the path of the right, length of the left path and the length of the right path. If these two numbers are solid, right? If these two numbers are not zero, right? Let me make sure I have enough time. Fuck, I don't have time to bullshit. Which means if these two are the same, if these two are not zero, which means the root is the same as the other two branches. So we can plus the left and right together, and then we will compare it with max. But if above the root node there is another node that is the same as value previous node, then we need to pick a side, or else it will have a fork, right? So if this is, then we'll return whichever is the longest, right? So we will return math.max and left or right, and then we'll plus 1. After that, we'll just return 0. Okay, so let's see, how much time we have? We have 2 minutes. I guess I don't have time to go through it with eyeball. So I'll just check 1 or 2 cases. So let's check another test case. What if we just have one node? And how about we have no nodes at all? Okay. 200. Okay, looks about right. 1 minute and 31 seconds. So yeah, so this is get the path of the left, get the path of the right. If both paths are not 0, then we will compare the max length with the sum of these two paths, right? And then if there's another same node, if this path also has a node on the above, it's the same as these, then we'll have to pick a side, right? Or we'll have a fork. So I have to pick this side is the longest. Looks about right. Let's submit it, right? Okay. Oh, accepted. Okay, then let's press on. I don't know. I just all of a sudden recently I just fell in love with Britney Spears. Anyways, so yeah, I guess we can stop the timer. Okay, so anyways, the takeaway of this is whenever we do a recursion of a tree, we just treat it like how we would do. You just imagine you're doing this recursion at the very bottom of the tree. See, so if we were to do this at the bottom of the tree, well, first we'll get the left, and then we'll get the path length of the left and the path length of the right, right? So if path length is the left path length is 0 and the right path length is 0, that means these two branches are not the same as the roots at all, right? So, I mean, there's no point comparing, then the max will just be 0 right here. But if left is something other than 0, some value other than 0, and right is something, it can be 0 or not, but then it will keep track of the path derived from this root. And then another circumstances is if node value is equal to previous node. So if this fork has a branch, has another node which is equal to the fork, then we need to pick a side or you also create a fork, right? So okay, so it was a pretty easy question, and if you like this coding challenges, please subscribe, and I'll try to submit these challenges regularly. Anyways, thanks for watching, and happy coding.